So we're going to subnet this one by increasing the subnet mask from what it is now is the first 16 bits to the first 24 bits. So we now have a network of 192.168.0.0 with a subnet mask of 255.255.255.0. So this is the same range of addresses as we were using before, but having this mask increased means that we can have more separate networks. Because it's increased by 8, that's 2 to the power of 8, we can have 256 different networks. Now looking down on the third line, the first of these networks will be 192.168.0.0. That will be its starting address or its network address. So the very first address after that is the first one that a device can use, which is 192.168.0.1. Now we can use every combination of these addresses outside the network portion, that is in the host portion, right up until the highest one, which will be all of these full 192.168.0.255. So that will be the broadcast address for this subnet. The second of our 256 possible subnets will be 192.168.1.0 as our network address, 192.168.1.1 as our first host. Once again, 2, 3, 4, and so on, right up until 192.168.1.255. So we can continue to increment this, so on. So there's 192.168.7.0 to 255 as one of our subnets, right up until we have 192.168.255.0 as our highest. Now the subnet mask does not have to be in groups of 8, as long as we continue to have in this mask all ones on the left and then all zeros on the right. You cannot have a subnet mask that has 1s, 0, 1, and 0. It has to be 1s and then at a certain point changing to 0s. So we have it at 24. The first 24 bits are 1 at this point. But if we increase this to 25, 26, 27, 28, 29, 30, then we now have a subnet mask of 255.255.255.252. Now remaining within our original range that we spoke about, we've now got 14 bits in our network portion. 2 to the power of 14 gives us 16,384 separate subnets to use. The first of these network addresses will be 192.168.0.0, the same as before. The first usable address for a device in that network is the next one on, 192.168.0.1. The next one will be 192.168.0.2, and the next one is 192.168.0.3. But because our host portion is full here, that is the broadcast address for this network, which left us with only 2 usable IP addresses if we exclude the network and broadcast address. So if we keep incrementing the network portion, add 1 there, we can see that our second subnet has a network address of 192.168.0.4, leaving us the 2 bits to use, which gives us 4 combinations, but only 2 are usable, taking out the network and broadcast address. The next subnet will be 192.168.0.8 and 192.168.0.12, and so on. So one more example using this same original range of addresses. If we had a subnet mask of 8, 16, 24, 5, 6, 7 instead, then it will represent a network of 192.168.0.0 with a subnet mask of 255.255.255.224, which is the decimal equivalent of these 8 bits. So we have subnetted it to give it an extra 11 bits on the network portion of the address, and 2 to the power of 11 means we now have 2,048 separate subnets available, each with 1, 2, 3, 4, 5, 2 to the power of 5, or 32 addresses available in each, and 30 that are usable if we take away the very first and the very last within the range. So if we have that and we're trying to work out our first usable address of our first subnet, We increment it by 1 from the starting point, 192.168.0.1 as before. If we fill up all these bits outside of the subnet mask, we will have 192.168.0.31 as the broadcast address, which means 1 to 30 are all usable. Increment our network portion by putting a bit in at the end of our subnet mask. And we can see that our second network address is 192.168.0.32. The first usable address in that range will be 33, and it will continue all the way to 63, which is the decimal equivalent of these 8 bits. Now we start again with one more example of how to calculate the range of addresses in a subnet based on address and subnet mask combination. From another part of the public IP address range, we have 10.66.64.0. We're given that address with a subnet mask of 19, otherwise known as 255.255.224.0 as the subnet mask. We can see that if we transfer everything from the top line to the bottom that was in the area covered by the subnet mask, we have 10.66.64.0 as our network address. We have 8, 9, 10, 11, 12, 13 bits to use for hosts. 2 to the power of 13 is 8,192. So take our 2 from the start and end that we can't use, 8,190 possible hosts or devices. And our broadcast address would be the one that we find when we fill everything outside of the subnet mask. And we have 10.66.95.255 as our broadcast address, or the last one in that range. Now this is too many hosts. We would take this portion that we are allocated, we would increase the subnet mask to something more usable, which has a smaller number of hosts per subnet, but a greater number of separate subnets available to use. We can see we've got 2 to the power of 4, which is 16. Take 2, maximum of 14 devices can be on that subnet. So by using a pen and paper with ones and zeros, you can calculate the range of addresses you have with any network and subnet mask combination, and you can also subnet it further to make it practical for use.